Okay, good morning everyone. Today we'll look at or continue our quest in solving exponential and logarithmic equations. Yesterday we solved exponential equations. Today we'll solve logarithmic equations, and for the most part we'll be making use of the fact that if log of A equals log of B, irrespective of the base we're talking about, then we can say with certainty A is equal to B, provided A and B are greater than 0. So before we actually solve properties involving logs, we have to remember our properties of logarithms. Before we solve equations involving logarithms, we have to remember our property of logarithms. So we have the product property, log base b of m times n is equal to log base b of n plus log base b of n. The quotient property, log base b of m divided by n is equal to the log base b of m minus log base b of n. The power property, log base b of a raised to the p is equal to p times log base b of a. We say we take log base b of a p times. And then the inverse property, and particularly b raised to log base b of x is equal to x. Yesterday, when we were working with solving exponential equations, we worked with that inverse property. Today, we'll work with the second one. All right, so let's take a look at this here. So here we want to solve log base 6 of 2x minus 1 equals negative 1. So again, the inverse of log base 6 of x is 6 raised to the x. So we just go 6 raised to both sides. So we undo it. So 6 raised to log base 6 of 2x minus 1 equals 6 raised to the minus 1. Well, that undoes that, and so now we just have 2x minus 1 equals 1/6. 6 raised to the minus 1 is 1/6. So I have to add 1, so 2x equals 1/6 plus 1 is 2x equals 7x, or yeah, 7x. 1/6 plus 1 is 7/6, and then I just multiply both sides by 1/2. And so that will give me x is equal to 7/12. Done, solved. Here I have log base 4 of 100 minus log base 4 of x plus 1 equals 1. Again, the inverse of log base 4 of x is 4 raised to the x. So we have to combine this as one log. We use the quotient property. 100 divided by x plus 1. And then we say 4 raised to both sides. So that undoes that. We have 100 over x plus 1 is equal to 4. And then I can multiply both sides by x plus 1. And so you get 100 equals 4x plus 4. 96 equals 4x. And then 24 equals x. Let's look at the next one. Here, I have one log, so we can use the power property. We just bring down the 4, and then we get 4 times log base 5 of x is equal to 8. Do not, I'm going to repeat this again, do not be tempted to now go 5 raised to both sides and 5 raised to that. That would be wrong. So what we do, we divide both sides by 4. And we get log base 5 of x is equal to 2. Then the inverse of log base 5 of x is 5 raised to the x, so we'll go 5 raised to log base 5 of x and 5 squared, and then that will give me 25. Again, I have log base 12 of x plus log base 12 of x plus 1 equals 1. I'll use the product property. I have to multiply x times x plus 1. And then the inverse of log base 12 of x is 12 raised to x. So 12 raised to that and 12 raised to that. So that undoes that. And now I have x times x plus 1 is equal to 12. Now I have to multiply. Okay, so this will give me x squared plus x equals 12. Subtract 12. I'll get x squared plus x minus 12. And now we'll have to find the zeros. So factor x squared plus x minus 12, and that gives me x minus 3 times x plus 4. Find the zeros, and I get 3 or negative 4. Okay, so because of this, I should verify my solution. So I want you to notice I have 3 and negative 4 as a possible answer. However, if I go back up to the original equation, there, I want you to notice I have log base 12 of x. Now the domain of a log function always has to be x is greater than 0. Which means I can't use negative 4. Right. Let's look at, okay, an important point here. When writing as one log, always undo the power property to solve the equation. Always undo it when writing as one log. Let me go back up to this one here. Here I had one log, so I brought down the 4. Well, that's okay. No problem there. I just have one log. But here, I'm combining logs I need to write as one logarithm. I really want to undo the power property. Okay, that's important. I want to bring that 3 up before I do anything else. All right, and so now I'll use the product property. 8 times x to the third is 8x to the third. Now I'm working with base 10, so the inverse of log base 10 of x is 10 raised to the x. So 10 raised to the third equals 10 raised to log base 10 of 8x cubed. That cancels out. And now I have 1,000 equals 8x cubed divided by 8. I get 125 is equal to x cubed, and the cube root of 125 is 5, or 125 raised to the 1/3, 125 raised to the 1/3. The cube root of 25 is 5. And one more example. Here I have to use the quotient property. I need to write as one log, but first I need to undo the power property. Always important when you're writing as one log and you're solving for logs, or you're solving log equations. Always undo that power property. So now I have log base 10 of x squared minus log base 10 of 4 equals 0. Now I can do the quotient property. So this is going to be log base 10 of x squared divided by 4 equals 0. I'm working with base 10. So 10 raised to that, 10 raised to 0. And that, now I have x squared over 4. 10 to the 0 is 1. Multiply both sides by 4. I get x squared equals 4, or x equals plus or minus 2 to negative 2. Check your solution. I go back to where I started. I see I have log of x. The domain of a log function has to be greater than 0, so I can't have negative 2. All right, so solving log equations is not too difficult. You just have to remember all of your properties of logarithms.